I most welcome everyone. This is a presentation by a group CS2411. Our project is about a machine learning model for quick bipolar detection and access to remote mental health services. My colleagues are Waskira Ian and Sanjuva Victor. Next slide, please. Next slide, please. So shall start off with the introduction. Bipolar disorder is a mental condition characterized by the extreme mood swings and includes emotional highs and lows. We have categories of bipolar disorder. We have bipolar type 1 and bipolar type 2. Bipolar type 1 has long episodes of lasting maniac episodes. So they go on for a while, and in extreme conditions, you're required to go to the hospital. Then in bipolar type 2, we have depressive episodes. They are not severe, like in bipolar type 1. In Uganda, currently we are suffering with mental illnesses, and we see that the count of people killing themselves is a bit high currently. So among those mental illnesses, we have the bipolar disorder. It's a fast-growing condition, and it's being shadowed by limited awareness, and then also we have inadequate mental health resources. For example, in Uganda, we only have one hospital that is dealing with mental illnesses, which is Butabika Hospital. Then, and also the interplay with genetic predisposition. This is where you're more likely to get a mental illness because your genes or your family members are also having this mental illness. Such things make its detection a bit complicated and managing the condition as well. So we have come up with a solution where we have a machine learning model that can, through asking you questions, the patient is able to answer those questions. Those questions are sent to a server where a machine learning model detects the particular kind of bipolar. If at all that person is sick, let's say bipolar type 1 or bipolar type 2, or if they are normal. The use of us detecting which bipolar type you have is, as you have heard in the explanation before, there are kinds. Bipolar type 1 is more dangerous or more severe than bipolar type 2. So if we know the exact one, it makes the treatment, it improves the treatment process. Yes? Yeah. Next slide, please. Next slide, please. So we're going to talk about the related works, the works that are related to our project. There was a machine learning model that was predicting the early onset bipolar using electronic health records. So this machine learning model was detecting the bipolar disorder using electronic health records obtained from hospitals. Its accuracy was ranging from 82 to 87, but it would predict the bipolar disorder in adults. Now, among the problems or the challenges this model was facing, there was reliance on structured assessments. These are clinical documents provided by doctors. Results. If that doctor doesn't diagnose you, then you won't be diagnosed as a sick person. So that would hinder the model's accuracy. Someone can be diagnosed, but since someone can be sick, but since the doctor did not say so, then the model cannot state that. Then generalizability and scalability. For settings like Uganda, this model would face challenges because in Uganda, we are having very many electronic health record systems. That means integration of those systems and the model becomes very difficult. And feature importance and causality. Remember, we have talked about bipolar type 1 or bipolar disorders depending on things like your genetics or DNA. So it's very hard for the model to determine which particular feature is more important than the other while detecting the bipolar disorders. This also hinders the model's accuracy. Next slide, please. The other piece of work was predicting features of human mental disorders through methylation profile and machine learning models. So under this model, they were using DNA samples to detect depression and bipolar disorder. They were using the Infinium methylation EPIC bit chip. So the biggest challenge these people faced while developing this model, there was overfitting of the model. They even tried to reduce the number of features being considered, and still the model was overfitting. Then the ethical considerations. This model, for it to work, or for the testing process, they had to obtain DNA samples from every patient, which made the documentation and the rights for someone because someone has to consent to you taking their DNA. It made it very difficult for the people who are carrying out the research. Next slide, please. So the problem statements, accurate and accessible mental health detection remains a challenge. The existing methods, as we have seen in the previous slides, make the existing methods over glimpses of potential solutions, but they are disturbed with things like being affordable or being unavailable, like the technology. As you've seen in Uganda, I've talked about only one institute that is caring for everyone, and the machinery is also not there. So many of these solutions are presenting that challenge, especially for a country like ours where the income is a bit low. So we decided to develop a platform where individuals can seek and also seeking for assistance. As we've seen, that we are having only one institute that is a bit distant. So as in part of the problem, also these people who are sick, they find it hard to get the assistance they need, which is also increasing the death count. People don't have anyone to talk to or anyone to help them out. So they end up taking their lives, which is also a big problem. Next slide, please. So the main objective of our projects, we are to develop a machine learning based mobile application for the detection of bipolar disorder and a web interface through which qualified mental health personnel can register and provide remote mental health services to individuals seeking support and treatment. Again, I can give a brief introduction about what we are doing or what we have done. So we have a mobile application. That's the one the patients will be using to answer the given questions, and they get a diagnosis, whether they are bipolar type 1 or bipolar type 2 or normal. And then there's also a section that enables them to meet professionals or psychiatrists to talk to. And then there's also the psychiatrists use a web-based application to manage the appointments of the patients and also payments. Then for the specific objectives, to collect a diverse data sets of several symptoms of bipolar type 1 and bipolar type 2 disorders. Then to clean, process, and collect data, handling missing values, outliers, inconsistencies, and extracting relevant features from the database. Next slide, please. To split the preprocessed data into training, validation, and testing sets, after which appropriate machine learning algorithms for bipolar disorder classifications are evaluated and selected based on the data characteristics. To train the machine learning model on the training set, optimizing hyperparameters using the validation set to prevent overfitting, followed by testing and evaluation of the model. shall use metrics such as recall, precision, accuracy, and the F1 score. Then to gather requirements, design and implement the system architecture and application interfaces, deploy and test them, and provide continuous support and maintenance. I'd like to call on to my next colleague to continue from here. Sanjuva, unmute yourself. You speak up.
Can you hear me now?
You are still low.
How about now? Fine. So I'm going to take you through the research contributions. And the first one is differentiation of bipolar types. So usually the problem happens whereby the conventional means they're only able to identify one type of bipolar and they generalize it as bipolar disorder. But we're able to focus on the crucial distinction between bipolar type 1 and the bipolar type 2 for more effective treatment, because I'm sure there are different treatments for each particular bipolar type. So that distinction is important, which you are able to achieve. Then the next research contribution was to provide a cheaper alternative. And this solution provides an affordable and more accurate way to detect bipolar types, as opposed to the conventional means, which involve DNA and such is expensive to carry out since processes of DNA methylation and anxious depression prediction in real time is costly. Next slide, please. So the next step in the report is the methodology, which looks at the processes we had to take through in coming up with the project results. And the first part we did was the research design, and then we went to data collection, we went to data analysis, people considerations, then the web application development, then we went into machine learning model development, and then we deployed the model. Next slide, please. So in detail, the methodology, we began with the research design. And in this process, we carried out qualitative methods used to understand the user's preferences and the potential users of a mobile app. And this was done through semi-structured interviews that were conducted with a few doctors we talked to help us understand the needs that an application would have in order to carry out the process of remote mental health care services. So we talked to counselors on call, and sometimes one-on-one. We were able to explore the benefits and challenges, the assessment techniques, the user preferences for the doctors. And this helped us to come up with the UI of the applications that we were able to come up with. Then the next stage was data collection. And for the data we used in machine learning, we got a data set from Kaggle. And a brief description of the data is there was 120 psychology patients that were interviewed and categorized among bipolar type 1, bipolar type 2, and then the normal individuals. And this was based on 17 essential behavioral symptoms that were that the 120 patients had, which enabled the categorization into the 3 types. So we also had one-on-one interviews with a few patients here and there, okay, potential patients to help us understand how the application that the patients could use, how it will look like, in other words. Next slide. So then we enter into data analysis. So in this stage, we analyze the data from both the patients and the mental health professionals to identify the common issues and potential areas of intervention. Now, the insights obtained, accompanied by the features in our data set, we obtained the list of the questions that we will be able to ask the users of the application in order to catch the behavioral experiences of the users and categorize and be able to diagnose whether they have bipolar type 1, bipolar type 2, or they are normal based on the trained model features. And so there's a questionnaire in the appendix that we came up on the questions that are being asked in the application. So the next part of the methodology is the ethical considerations, and this was taken into account for things like informed consent. We're able to make sure that during the interviews as well, that it was consented that we ask we had to first get consent from the doctors. We asked patients. Then another consideration was anonymity and confidentiality. So for the different interviews and the data collected, we make sure it's secure and it's not exposed. Then data security was also another aspect that we took into consideration, so that the user data is secure in the different applications. So the next stage in the methodology was the mobile web app and the mobile app and the web app development and deployment. So we developed the mobile app and the application following the SDLC, the System Development Life Cycle. And the stages in that cycle were analysis, where we analyzed and were able to come up with the requirements for the applications, for the different applications. Then we went on to design the architecture. So we drew out planning on how the application would be used. We used use case diagrams, we did, and user stories to come up with how the architecture of the applications will look like. Then we went on to implementation and testing phase, whereby we obviously, after developing the app, we test it out among users. We took it to a certain doctor to see how the UI would be and suggest improvements. Then we went ahead to deploy and evaluate. So after deployment, we got feedback from a few potential patients who we asked to help us go through the applications and understand whether it satisfies some of the users' needs. So the next stage in the methodology was machine learning and model deployment or development. And in these steps, we went on to collect data, like I talked about. We got a data set from Kaggle. We defined or identified the data set features, which were several of them. We went ahead to do data cleaning and pre-processing, whereby we had to remove some empty values, remove duplicates. Then we went ahead to split the data into training and test sets. And then we went on to model selection, where we got a bunch of models and we iterated through each to identify which is best for our use case or our need. Then we went to model training, whereby we trained the best model that we identified. And there was model evaluation, evaluating the output of the different models and understanding the accuracies. Then we went on to optimization and validation. So we also did optimization of the models to achieve the best possible results and the best possible score. Next slide, please. Then one last phase we did in the methodology was the support phase. So obviously, as after completing the app, we're going to be able to receive periodic updates. I mean, the app will receive periodic updates from the different issues we got from the users. So we update those, and so we make the applications, both the web and mobile, as optimal as possible. And this was based on the user feedback that we did during the application evaluation. So this will enable the application to be usable, functional, and providing continuous support for the users. Thank you. So I'll invite my next colleague to.
Thank you. I'm going to take you through the dataset description, the model training, and the different steps we took to achieve the completed model, and the predictions and some of the results that we got. So the dataset we got was from Kaggle. As mentioned by my colleagues, it had the collection of 120 patients. This dataset had 17 essential symptoms from which someone can diagnose bipolar type 1, bipolar type 2, and normal individuals. So these are based off different symptoms, such as how often someone feels sad, if they have any sleep disorders, if they feel exhausted often. Such symptoms are what we took into consideration. So this dataset was in a CSV format, and it has those features that I've mentioned, some of the features that I've mentioned, but these are the rest of them. After training, we obtained the results shown in this table. So the stacking classifier, which is an ensemble of all the models, including the support vector machine, the random forest classifier, and the logistic regression, came up with an accuracy of 83. The voting classifier, also an ensemble model, came back with an accuracy of 83. We also had the random forest. Random forest on its own had a performance of 83, same as support vector. And then we had logistic regression emerging with 88%. So each of these models had their strengths and weaknesses that we analyzed in our discussion of results. Here, we show that logistic regression came out as the top candidate to make these predictions, as it exhibited strong performance across all four classes, from normal to bipolar type 1 and type 2. So for support vector machine is a machine learning model that finds the best hyperplane that best separates the classes in the feature space. So the reason why we used it is it handles multi-class classification very well, and it's also good for small to medium-sized data sets. In our case, which is very valid because we just had a total of 120 records for training these models. Then we have logistic regression. Logistic regression is a probabilistic machine learning model that bases on the value of the probability to make a prediction. So reason why we use this is that it can be extended beyond just binary predictions. And in our case, where we're making up to 3 predictions, it was very suitable, and it stood out. It was able to stand out and make good predictions as well. So it's also good for probabilistic interpretation, which is also necessary in such cases where we're making multiple class predictions as well. Then we also use the random forest. Random forest builds multiple decision trees and merges the outputs into one that merges the outputs in order to improve accuracy and control overfitting. So we used random forest because it provides insights into feature importance, and it also doesn't require so much data preprocessing. So it is a very robust model, and it works very well on such data. So yeah, as also mentioned, it was able to handle feature importance effectively, and thus performing very well as well. We also used the stacking classifier ensemble model. Yeah, we used it because we wanted to improve the performance of the support vector machine, the random forest, and the logistic regression model. So yeah, the reason for this, as I've highlighted it combines the strength of these multiple models, and in doing so, we expect a higher performance to come up from them since it's using their strengths. Then we also chose it because of the versatility that I've talked about and its ability to combine the strengths. Same thing with the voting classifier. The voting classifier is also an ensemble model. The way it works is in such a way that it chooses the prediction that has the most votes from each model and takes that as the final prediction or as the output for that particular input. So it is robust to errors on individual models with correct predictions compensating for poor ones. Then we chose it because of its robustness and its ability to improve overall prediction accuracy. Yeah, then from our research, we came to the conclusion that logistic regression had the highest accuracy of 88% with balanced precision and overall good performance across all three classes of bipolar type 1, bipolar type 2, and normal individuals. SVM, random forest classifier, the stacking classifier, and the voting classifier came in a shared second position as they had the similar performance across all classes. So logistic regression proved to be the most robust model for this data set with a balanced precision and recall across all classes. SVM and random forest had specific strengths, but struggled with class imbalances. So these are our references, including work that we cited throughout our research in order to acknowledge the different work that was done before us. And from this, I would like to thank you for your time, and we are grateful for this project, and we hope for all the best. Thank you.